we are starting again. Okay, so we have reached up to this slide, that is molecular formula, isomer number, and kekule structure. Now, before kekule has put forth the structure in front of us, he don't know how the all 6 carbon and 6 hydrogen atoms are arranged in the structure of benzene. He don't know about this. Okay, so benzene has a molecular formula. We know all of us, that is, he is going to contain 6 carbon atoms and 6 hydrogen atoms from its elemental composition, and molecular weight of benzene was known to contain again 6 carbon atoms and 6 hydrogen atoms. But the question is how these all atoms, that is 6 carbon and 6 hydrogen atoms, are arranged in the structure. In 1858, Auguste Kekule of the University of Bonn has proposed the carbon atom can join to one another to form the chain. See, he has put forth that carbon has a tendency to join with each other to form a chain. And again, in 1865, he also offered an answer to the question of benzene. These carbon chains can sometimes be close to form the rings. See what he has proposed. In 1858, he has proposed that carbon atoms can join to form. So see, the carbon has a tendency to join to each other and form a chain. And again in 1865, he offered an answer to the same question, that how the carbon atoms are arranged. Sometimes they are arranged in the form of closed chains. Now he has given the structure. So kekule structure of benzene was one that represent. Now, out of these all 5 structure, every one of us what will be the structure of benzene? Yes, this is the structure of benzene. So other structures are, of course, see, the slide consists of 5 structure. All are of contain carbon 6 carbon atoms and 6 hydrogen atoms in the structure. So first structure we know all of us, it is the structure of benzene. Now the second one, bit quite simple to the first structure of benzene, but he is going to possess only carbon-carbon 2 double bonds. The third one, we know the benzene membered six-membered ring, but here the carbon 5 carbon atoms are arranged in a chain, and the 6th carbon atom is inside the ring with the help of carbon-carbon double bond. See the similarity. This compound is also possess carbon-carbon, 3 number of carbon-carbon double bonds, as like the benzene, but 1 carbon atom is outside the ring. In fourth structure, again, this structure is also possessing C6 and H6. 6 equalized electrons are there, but instead of possessing carbon-carbon double bond, there is carbon-carbon triple bonds. Rahul, mute yourself. Now, a last structure, that is fifth one. Now, in this, there is also a presence of 6,6H6, but the middle carbon atom is joined with carbon-carbon triple bond, and the terminal 2 carbon atoms are joined with carbon-carbon double bond. So all these structures are containing 6 number of carbon atoms and 6 number of hydrogen atoms. See all the structures, of course, consistent with the formula C6H6. For example, structure number 2 and structure number 5. Of all these, a kekule structure was accepted by most of the he is going to give nearly all satisfactory result for the evidence was of kind which are already familiar with the isomer number. So these are the isomers of benzene will containing 6 number of carbon atoms and 6 number of hydrogen atoms. So Kekule has given for all of us, this will be the structure of benzene. Now, benzene yields only one mono-substituted product. What is the structure of benzene? We know the structure of benzene is he is going to possess 6 number of carbon atoms and 6 number of hydrogen atoms. But when this benzene is undergo a substitution reaction, in second and third slide we have discussed that aromatic compounds generally prefers for which type of reaction? So they generally prefer heterocyclic substitution reactions. But benzene is undergo for only one substitution reaction, that is mono-substituted product. How? He is going to substitute one of the hydrogen atom in the benzene with the help of any another group. So what will be the remaining structure or resulting structure? C6H5Y. This Y will be a substituted product. Only one bromobenzene. See? So the here the Y will be or Y may be bromine. So only one bromobenzene is obtained when one hydrogen atom is replaced by bromine. Similarly, only one chlorobenzene, that is one chlorine atom, is substituted instead of hydrogen atom in the structure of benzene, or one nitrobenzene by substitution of one hydrogen atom of benzene with the help of nitro group has ever been made. This fact places a severe limitations on the structure of benzene. Each hydrogen must be exactly equivalent to very other hydrogen atom. See, all the 6 hydrogen atoms of the benzene structure, those are situated exactly equivalent, since the replacement of any one of them yield the same product. So out of these 6 hydrogen atoms, if we can substitute only one hydrogen atom, so they are going to give the same product. So structure fifth in the same structural series, the structure fifth, for example, must now be rejected. Why? Since it would yield two isomeric monobromo derivative, that is 1 bromo and 2 bromo. So there is substitution of bromine at this position as well as at this carbon atom as well as at this carbon atom, because this is an free radical derivative. So Rabia, so structure fifth, for example, must now be rejected since it would not yield two isomeric bromobenzenes, 1 bromobenzene and 2 bromobenzene compounds. All the hydrogen atoms are not equivalent in this structure. See, the benzene structure is too much conjugated one. They will migrate their double bond from one carbon atom to the another. So they are all at equivalent position. But this is not the case with this fifth structure. Some carbon atoms will have carbon-carbon triple bond. Some carbon atoms are there will have the carbon-carbon double bond. The terminal carbon atom means carbene derivative. So all hydrogen atoms are not equivalent in the case of structure 5. So similar reasons show us that structure second and third likewise unsatisfactory. The same reasons will be applied to the structure number 2 and structure number 3. So structure number 1 and 4 among the others. So these are the reasons we know that the benzene structure is too much complex in nature. They are conjugated, they will migrate the double bond from one position to the or from one carbon atom to the another. So this will be the acceptable structure of benzene from Kekule. But before this structure, Kekule has given these many structure series. to all of us. However, benzene is 3-isomeric di-substitution product. Up till now, we know that benzene is undergo for only one substitution or mono substitution. Now, benzene can be undergo a di-substitution product in special case. That means we can expect 3-isomeric dibromo derivatives, that is either 1,2-dibromo or either 1,3-dibromo or either 1,4-dibromo. In special conditions only benzene is undergo what type of substitution? Di substitution. So 1,2, 1,3 and 1,4-dibromo benzene. Closer examinations of structure 1 shows, however, that 2,1,2-dibromo isomers. If benzene is going to substitute from right hand side or from clockwise direction, he is going to give the dibromo derivative in this manner. Or if bromine is substituted, see this will be the structure, same structures, this and this. So if the bromine is substituted in clockwise manner, he is going to give this type of structure. And if it is substituted anti-clockwise manner, the name of the structure is same, 1,2-dibromobenzene, but the substituted carbon atom is different. So close examination of structure 1 shows that 2,1,2-dibromo isomers, that is 6th and 7th. So these are the two isomers given by the benzene, which are differing in the positions of bromine relative to the double bond. So this can be possible when benzene is undergo di-substitution reaction. So he described that